today Sean Regalado, who's from Paul Smith's College. The floor is yours.
Thank you very much, Lindy. I'd like to share with you guys some of the work I've been doing delineating road salt discharge in Adirondack Park. The ecological impacts of road salt are well known. Hundreds of papers have been published analyzing the effects of road salt on soil and water chemistries and the subsequent biological systems they impact. But to date, there's been little study examining the spatial extent of these impacts, especially with regards to the entire Adirondack Park. The goals of my study are to A, quantify the total area of terrestrial land impacted by salted overland flow, B, identify the water bodies intersected by salted flow, calculate the total surface area, and C, quantify the total length of rivers and streams impacted by salted flow. I'm basing my hydrological modeling on a mosaic 10-meter USGS DM in the entire 2.4 million hectare Adirondack Park. I'm using a modified flow accumulation tool developed by Dr. Tarvin from Utah State University. Okay. There isn't a concise data set of road salt applications in the park, so I'm using 3 hypothetical road salt applications: state, state and federal, county, state and federal, and local, county, state and federal. And here are my results from my flow accumulation. This is examining the downslope area of terrestrial land, downslope of roads. For reference, these are percentages based on the total area of the park. So if only state and federal roads are salted, only 2% of the land is impacted by overland flow, and then ranges up to 10%. I have the same percentage process for the total impacted water bodies. I'm just finding intersections with salted overland flow, and then I'm finding the downstream length of streams impacted by salted overland flow. Here's a little map representing the overland flow downslope of roads in 3 categories. This is the zoom in on Saranac Lake. There's state and federal, county, state and federal, and local, county, state and federal. The white area is the downslope area, but I'm just finding how much land that covers. Implications. It provides relevant study designs for further research of the ecological impacts of road salt applications. Also, my study illustrates that not every kilometer of road impacts the same total area of land, or the same number of water bodies, or the same total length of roads. So applying a more expensive alternative in high impact areas may be a more socially acceptable solution. Also provides a new parameter for doing ecological modeling in the park. So understanding why things are a certain stream may be better understood by road salt applications. Any questions?
Okay.
Yeah, have you looked at the different media that the salt is put down, whether it's crystalline or a liquid agent, and does that have a different impact?
I haven't looked into that. I'm just modeling where water would flow.
Okay.
Downslope roads, and salt readily dissociates in water. That's my reasoning.
What's the next best alternative to salt?
I guess there really isn't. I mean, you use magnesium chloride, calcium chloride. They're less of an impact, but they're more expensive. Or using chains on your tires.
So I saw you had a picture of Cascade Lakes, which is notorious for being impacted. Have you been finding other hotspots like Cascade Lakes since?
Oh yeah, it's my results are easily divided among watersheds throughout the park. So you sort of just have a watershed polygon, then find out how many salted cells there are,